not moving.
How do you know?
Because it's the force of static friction.
Okay. Okay. Is there another way you can tell? Because, like, how do you know? Because here's what I'm thinking. I know that when an object moves at a constant velocity, what's the acceleration?
0.
0. So how do you know that this picture here isn't for a block that's sliding down the incline at a constant velocity?
Because static friction is not sliding.
Static friction means no motion. So for this one, the acceleration is 0 and the velocity is 0. Emily, you get next pick.
The bottom left.
Okay?
Like moving down.
What? How can that be? Friction is more than FGX.
Because the forces moving down are greater than the forces moving.
Forces moving down? What are you talking about? I see FGX.
And the applied force.
Oh, and the applied force. So you're saying these two together are more than the force of kinetic friction. So the block is moving down. How is it moving down? Is it moving with a constant velocity? Is it accelerating? Is it speeding up or is it slowing down? So it's accelerating. So the velocity is down the incline and the acceleration is down the incline. So it's moving and accelerating in a positive way. It is speeding up. Alex, there are two left. Select.
Top right.
Top right.
That looks like if you add the two forces of friction together, they're the same as applied.
Hold on. Add the two forces of friction.
The one force of friction and the force of gravity looks the same as.
So the orange one and the green one?
Yeah.
The green
No,
one's
not the green one. The red one.
Oh, FGX, that component of the force of gravity. Okay, so the orange one and the red one, what about them?
They look like if you add them together, they're the same as the applied force.
Okay.
So it could either be stationary or it could be moving up at a constant velocity.
So what's the acceleration?
0.
Acceleration has to be 0. So it could be stationary? Are you sure? Or is it
No, kinetic friction. So
kinetic friction? Okay. So it must be sliding. And it's sliding at a constant velocity, right? Which way is it sliding?
Up.
How do you know?
Because the applied force is forward and friction pulls back.
The applied force is up this way. Does that necessarily guarantee that the box has to be going up the incline? Not necessarily. So which way is it moving?
It could be moving either way.
Either way, we don't know. We don't know. How do I express that? Like that. Crystal clear.
I'm hungry.
Me too.
Got some muffins?
No.
Do you have anything in that refrigerator?
Grilled cheese
That's
and breadsticks,
cool bars.
please.
There's only one left. Choose the bottom left. Right. Okay, good choice. Wait a minute.
Gasp.
I'm totally wrong.
Yeah.
You agree.
No.
We have it on video too.
Why, Tim?
Because the force of kinetic friction is that way, and it's fighting the way it's moving.
Friction always opposes motion. Is it? I didn't hear that part of it.
He didn't explain it as well. That's what he said.
I had refrigerator sliding down the stairs on the brain, I guess. Because I was thinking to myself, this should be an extra example of discussion physics tomorrow. I didn't say that though. You know?
He's on video.
Because I was with my girlfriend, I gotta be cool. You know?
Oh, yeah.
Send that to his girlfriend.
Really glad this is going on YouTube. Right now. So how about this one then,
Look at
Matt?
I carry down everything downstairs. We should record him every time he mentions his girlfriend. Cut it, make a little seconds and send it to her.
Yes, Mr.
Have a montage from.
We'll send it to her on Valentine's Day.
Perfect.
I request a
How's it
100 on
moving,
my
Matt?
test now.
It is moving down and probably at a constant velocity
Why do you say so?
because it looks like if you add the applied force and the force of friction, it would equal the force of the X gravity.
So does it matter that these look to be about equal to each other?
No.
No, it does not. What matters is that they add up to a force up the incline that looks to be about equal to the force down the incline. So we'd have motion down the incline, acceleration would be 0, and velocity would be constant. I wanted to do something like this to get you to just think about the force diagram, because really, with these kinds of problems, there's nothing more important. These two. The force diagram is the basis upon which all of your equations are derived and your answer. Without it, you can't possibly get the right answer. A lot of reasoning goes into it as well. Anything about that that you'd like to ask? Yes, Adam?
So basically, the bottom right is different than the top right because friction is going down the inclined plane on the top right and friction is going up on the bottom. So basically it'll just go wherever friction isn't going.
Yeah, and this is a picture for what I did last night on the with the refrigerator. Turn that thing on! And doesn't it make sense that it would be easier to slowly ease a refrigerator down some stairs rather than to push it back up the stairs at a constant velocity?
Hopefully it's okay. That's how I get mine down there. Did you feel it?
What?
You have to leave the refrigerator now?
No, it's not plugged in, there's nothing in it.
Then you can follow it down with each sliding one.
Anything else you'd like to talk about? Alex?
That'd be awesome.
Projectile motion. Okay, well, there's the kind where it ends up at the same height where it starts, and then within that type, there are two kinds. Where you have the velocity and the angle, and you're asked to find other stuff, or the kind where you have other stuff, and you're asked to find
It like slides down.
velocity and the angle.
No.
And then there's the kind where it starts out